All right, guys, here we go. Let's get going with our work today. Today we're going to work on writing decimals as fractions. I have two examples for you. First example is writing terminating decimals as fraction. The second example is writing repeating decimals as fractions. So first let's go over terminating decimals. Those should be a little quicker, a little easier to work with. When I'm writing terminating decimals, you just have to say the number, and if you say the number, then that will help you answer it. So for the first one, 0.7, that's how most people say it, but the real way to say that is 7/10. So I'm just going to write that out, 7/10. I can't reduce that, and that ends up to be my final answer. Now you have to remember your place values for these guys. So remember, 1 after the place value is tenths, then hundredths, then thousandths, then 10,000ths, 100,000ths, millions, and so on. Okay? This one just went to tenths, so that's all we had to do. In example B, I have negative 3.05. Now for that one, I'm just going to write it out. And again, I'm going to remember my place values. The first one is tenths. The second one is hundredths. Okay? So I have negative 3, that's my whole number, and 5 hundredths. Okay? Now I can reduce that, so I am going to reduce that. And 5 goes into both 5 and 100, so I'm going to reduce those both by 5. And when I do that, I'm going to end up with negative 3. Do not forget your whole number when you simplify. A lot of people do. Please don't. And 1/20th. So I get negative 3 and 1/20th. And that is my final answer. And that's how you turn terminating decimals to fractions. Again, just think of what the number actually is. Think of your place values. The whole number stays your whole number. That doesn't change. The numbers after the decimal point you write over. And basically it's powers of 10. Tenths, hundredths, thousandths, and so on, depending on how far it goes. In example 2, we're going to be writing repeating decimals as fractions. This is going to require a lot more work, and this is going to require you guys to use your solving equations work. So pay attention. I'm going to put some notes on there. Yes, you must show all of this work as you go through and answer these questions. So if I want to know what 0.93 repeating is as a fraction, okay, I know it's a fraction. It's a rational number. It can be written as a fraction. So what can it be? Repeating numbers can be written as fractions. So how do I write this as a fraction? First thing I'm going to do is I'm going to set my number to a variable, equal to a variable. So I'm going to use x. X equals 0.93 repeating. I've now turned it into an equation. It was not an equation, but now it is an equation. So now I can solve this equation. How do I solve it? Well, here's the first step, and this is a harder step to think about. First thing I'm going to do is I'm actually going to multiply both sides by 100. Why 100? I'm multiplying by 100 because I have two repeating digits. Not that I have two numbers after, not that I have two numbers after the decimal point, but that I have two repeating digits. The 9 and the 3 are both repeating. So I'm going to multiply those by 100 because that is 10 to the second power. And that's where my 100 comes from. Okay? Do your math. 100 times x is 100x. This ends up to be 93. Move the decimal point over 2. Point, remember, it's repeating, so I still have 9 3's afterwards for as long as I need them. Okay? Now that's my first step. Okay? Now the next step is tough again. I'm going to do a subtraction problem. I'm going to subtract both sides by the same value, but I'm actually going to write two different things. I'm actually going to subtract by the original problem. Since x equals 0.93 repeating, I'm going to subtract this side by x, and I'm going to subtract this side by 0.93 repeating. Now they equal the same thing because up here in step 1, I have x equals 0.93 repeating, so I can subtract by the same value. Okay, so you're actually going to subtract by the original problem. Okay, so my original problem that I set up, I'm subtracting by. Do your math. 100x minus 1x is 99x. Equals. Well, they go on forever, but they're always going to match. 9 over 9, 3 over 3, 9 over 9, 3 over 3. So they're going to end up crossing out, and you're going to be left with 93. Okay, now I have easy one-step equation. Divide both sides by 99. I get x equals 93 99ths. Okay, which can be reduced to 31 33rds. If you want to check it, go ahead. Take out your calculator and divide 31 divided by 33, and you will get that. Okay, so that's our first example. of repeating decimals to fractions. I'm going to do another one to show you. Okay, so I'm going to move to the next page. If you need to pause, go ahead and pause. In our next example here, I have 2.16 repeating. Just the 6 is repeating. The process is going to be the same, but we're going to be a little different. So I'm going to go over this one. First thing I'm going to do is I'm going to set it to a variable. Now I'm going to ignore the 2 for right now. Okay? It's easier to do the problem if you don't think about the 2. So I'm just going to do that. So I'm going to make x equal to 0.16, just the 6 is repeating. Now I'm going to multiply both sides by 10, not 100, because I only have one repeating digit. Okay, doesn't matter if there's 2 digits after the decimal point. I only have one repeating digit, which is 10 to the first power. So this exponent represents how many repeating digits I have. Again, repeating. Now I'm going to do my math, so that's 10x equals, this ends up to be 1.6 repeating. Alright, now I'm going to subtract my first step. So I'm going to do minus x here, minus 0.16 repeating here. Now it's not going to look like it lines up very well, but don't worry, I can get rid of the repeating bar there because I can add a 6 there and make that repeating. Oh, now the 6's there will line up, so they're going to cross off. I can do my work here. 6 minus 1 is 5. Decimal point moves down. I get 1. 10 minus 1 is 9x. So I get 9x equals 1.5. Okay? This makes it harder because now I'm dealing with decimals and eventually fractions. Alright? Now what I'm going to do is divide both sides by 9. That's going to get rid of those. So I'm going to get left with x equals 1.5 ninths. Now you cannot leave a decimal in your final answer in a fraction. So I have to get rid of my decimal point. Easiest way to get rid of the decimal point, multiply this side by 10 and multiply this by 10. This is an equivalent fraction. 1.5 times 10 is 15. 9 times 10 is 90. You have now rid yourself of your decimal point. So that's just using equivalent fractions. That's why we work on equivalent fractions, so that you can use them in situations like this. Now I can reduce that. 15 actually goes into both of them. So I'm going to divide both sides by 15. And you're going to get 1/6. Now look at my final answer. We ignored the 2 for now. Now I'm going to stop ignoring it. So my final answer is 2 and 1/6. And this is just happenstance that it happens to be 1/6 and it's 1 and the 6 repeating. Okay? So that doesn't happen all the time. This is a unique situation. Okay? So that's it for tonight, and you will have we'll work on these tomorrow. All right? Have a good night, and if you need to go back, rewatch the video, make sure you write these down.